of slope, and we have we've talked about this before, the slope intercept form, which is just a way that we can write lines in a way that's kind of the same each time. So this y equals mx plus b, this away, there you go, is what we call slope intercept form. And that's what we'll be using the rest of this chapter, and kind of next chapter is all about this slope intercept form. But it has two pieces. X's, we're going to talk, X's and their Y's are just kind of your inputs and your outputs and can stand as a point. The two pieces that we're going to focus on today is this M value, which is a number, and it's just our slope. And then our B value, which is your y-intercept. So remember, an intercept is where your line that you're graphing crosses the y-axis. We also can call this, when we're gonna be counting, this is kind of the starting point that we're gonna take. You can sit in the back there next between Maggie and Ryan. Yeah, so our starting point, so we're going to find that point first and then count from it using our slope. So if we look at our first example, we have y is equal to 3x plus 4. What I always suggest doing is finding the two pieces. Figuring out which number is your slope. Well, that would be, we look at y equals mx plus b. It's always the number that's in front of your x. So your slope is 3. But yesterday we talked about slope having a rise over a run. This is just a whole number, right, as it is. So we need to add something to it to be able to make it a slope. So we always write it over 1. Jose, you can grab a sheet and sit next to Keyshawn. So our slope is 3 over 1, not just 3. Why we want it as 3 over 1? So we know how many we need to go up and how many we need to go over. So whenever your slope is just a whole number and not a fraction, put divided by 1, right? Because numbers are always divided by 1. Divided by 1 doesn't change anything. Well, then our second point that we're looking for is our B number, and that's a positive 4, just from coming from right here. And that's where we're going to start from on our graph. Remember, that's our y-intercept. So we're looking on our y-axis, so the up and down bold line where 4 is. So I'm going to count up 4 boxes, 1, 2, 3, 4, and draw a point. And I always like to label that point so I know this is 4, this is my y-intercept. You can sit across from Bailey and next to him over there. Whoever comes in late has us in the front. Yeah, that's fine. So from here, we're going to count. From this point, we're going to follow our slope. If 3 is our change in y and 1 is our change in x, that means we have to count 3 up and 1 over. So I'm going to count 3 boxes up, 1, 2, 3, and 1 box over, and draw another point. From that point, I'm going to do the same thing. The point that I just drew, I'm going to count 3 up, 1, 2, 3, and 1 over, and draw a point. Once you have 3 points, that's enough to draw a line through them. So you draw a straight line. It should be at a diagonal. Try to get it as straight as you can through the middle of each point. And there's the graph of your line. Ben and Ayana, you guys both sit up at this table. Is that okay?
Why do you 3 points?
2 gives, if you just draw 2, people tend to their line times to kind of be crooked. 3 at least makes it like a little more straight.
So it's not necessary.
For me, I always say, like on a test, I say you have to graph at least 3 points. The more the better, but 3 is the minimum. And that's kind of just all we're doing. So we'll look at the next one. And now it's negative 2x plus 5. So this negative 2 is our slope, and that's a whole number. So we're going to put it over 1 and say, okay, well, our slope now is negative 2 divided by 1. So we're going down 2 and over 1. Sometimes you'll see, if you want to put like a nice reminder for yourself, you could draw arrows to show, okay, I'm going down 2 and then to the right 1. Some people find that helpful just to remember going down then over. And then our B number, or our y-intercept, is positive 5. And I always write it as plus 5 just so make sure I'm counting up on my axis and not down. So now I'll do the same thing. I'll start from the middle of our graph, which we call the origin, and count 5 up. 1, 2, 3, 4, 5. Draw a point there. This is 5, our y-intercept. From there, we just follow the arrows that we had. We have to go down 2 boxes and to the right 1 box. So down 2 boxes to the right 1 box. Down 2 boxes to the right 1 box. We have 3 points. We can draw a line through it. All right. 2 more. C, we know what our slope is. Can anybody guess where we should start from? 0. We could always write plus 0. Writing plus 0 here doesn't hurt us at all. Again, like I say, when we're being math people want to be as efficient as possible, so we don't like writing that plus 0. We just say, okay, we're starting from our origin of our graph. We're going up 1 over 2. Our slope is already in a fraction for us, so that's nice. We want to draw the arrows again. This is going up 1 to the right 2. Since they're both positive, we're going up and to the right. And we're starting from 0. So starting from 0 is just where our 2 axes meet. So you have to go up 1 over 2. 1 over 2. 1 over 2. And you could keep going, like if you wanted to, you could add more points. It's easy enough. You really are kind of like things looking neat. One thing you can always do too, which is kind of nice, say you don't have enough room for points, you can always reverse direction. Instead of going up 1 and to the right 2, if I go from this point and go down 1 to the left 2, it still is going to stay in line with everything else. Down 1 to the left 2. It still keeps all the dots in a line. You go straight line through. See, that wasn't the best line because I didn't go through all the dots. That's better. All right. I'm going to give you a second. Try doing the last one on your own before I put it up on the board. If you already did it, that's great. You're ahead of the game. All right, so it should look something like this. Here's one quick kind of thing that's not on your notes, but I want you to think about. I'm just going to do this down here on the bottom. Let's say we have an m value and it's written as negative 3 over 4. And the negative is not really assigned to one or the other. It's kind of in the middle. This means that depending on which way you're counting, the negative can go to either. And I'll use the last example as kind of what I mean. So here we went down 3 over 2, right? Starting from this point, down 3 over 2, down 3 over 2. I could have this as equal to 3 over negative 2, because what this says instead is say, okay, count up 3, 1, 2, 3, and over 2, 1, 2. I'm still ending up on my line. So it doesn't matter whether your negative number is on the numerator or the denominator, it's still going to slope down. Remember, sloping down means negative slope, going uphill is a positive slope.